Morning learners. Today we will see what are the different tabs that are available in our PSpice software. In the last video, we have installed the PSpice software. Today we will try to simulate or how to we know how to simulate the programs we are using Capture CIS software. So click on the search button and type Capture. So then it will open. So click on open, then a window will be opened. So this is the window where you need to create your own file. So first you need to go for file, new project. So in this project, first you need to browse where you need to save the files. So here we have different locations. Either you may save in the current drive, or you may save in your drive where D and E, like that you have different ways. So I have chosen a D. So in this I have chosen PSpice software. So PSpice folder. In this folder, whatever the programs from now onwards I will do, it will be stored in this drive. So click on OK, and then here click on OK. Then so here if you observe, the location is D. In D drive I have PSpice folder. In this PSpice folder, whatever the programs I'm doing right now will be saved. After that we need to give the file name. So what in which name you need to save the file. So suppose this is mesh analysis, MESHANALYSIS, mesh analysis, and then click on OK. So if you click on OK, a file with mesh analysis name will be created. And here we have analog and mixed signal, AD signal. So here you can go for continuous signals and discontinuous signals, whereas PCB wizard means so this is the design for PCB boards. And then we have schematics. So right now we are using analog or mixed AD project. So click on OK. If you click on OK, it will ask for how to create. So do you have any continuation for the existing project, or is it a new project? So here you need to click on blank project. So when you click on create blank project, a fresh copy of your project will be opened, and click open. So if you observe here, this is the window where you need to connect the circuit diagrams or the given circuit, and then you can simulate the circuit diagrams in this space. So for this, first we you can zoom it. First we'll see what are the options that are available in this PSpice software. So this is first one is file. In file you can create new project, or open an existing project, or close, or save. Along with that you can do print option, and you can search any recent projects that we have done, and you can exit the software. After that, in edit menu, we have the different copy, paste, and rotate, like that. And then in view menu you can go zoom, and then you can uh, eh, have the tool palette, toolbar, and then status bar, like that. And then place part. So in place, so you can use these places. So you can identify the parts, databases, connection of wires, and different. So whatever that can be used in your this space, you can use it here. And we have title block, and then bookmark, text line, and then rectangle, ellipse, like that we have different. And then in macro, so we can configure and we can record whatever we are doing. And then PSpice. So here this in PSpice we have, if you want to simulate that, you need to create the new profile, new simulation profile, and then you can run the program. Once if you create the new file, then the run button will get enabled. So all, if you observe here, all these are in all are grayed out. And now once you create a new simulation profile, this simulation profile you need to create one only after connecting all the circuit diagrams. Then you can create it. And accessories, options, and then window. So where you can have a new window, or you can have a cascaded window. And then help. And if you observe this bottom ones, here we have new file. So if you don't want to go for file and create new project, Directly you can click here, you will get the new file, and then open folder, and then save document, print. And these are the some other cut, copy, paste, like that, redo, undo. And this is zooming. And then here if you observe, these are the simulation tools that are we use regularly. So first one is create new simulation profile, and then edit simulation profile, and then run in PSpice. And then if you want any C waveforms, this button is used. And these set of buttons are used for marking purpose. Markers are used for kind of like a probe, where you can get a continuous voltage or continuous current waveforms by using these markers. And then just you want to display the value, or what is the voltage or what is the current in your circuit, then you can go for this display of vi and w, so voltage, current, and power. Similarly, when you come to here, the extreme right end, so the first one shows the pointer, mouse pointer. Second one, place part. So place part, so in place part, if you observe here, whatever the components that are available in PSpice software, all components are there in libraries. You need to install these libraries. If you don't have any libraries installed, you can directly go for add library, select all these files, and then click on open. Automatically all the files will be get established, sorry, installed. And you can search. So these libraries, each library contain different elements. So in each library there is a set of parts, and these are the list of available parts. So and right now I may go for resistance, like that. So when you click on resistance, it will show the part name here, and then the symbol that you are using, so normal, and then you can use it. And then if you click on OK, then you can add it to the library, add it to the workspace. So clear. Then after part list, we have another place where, so if you want to connect in between two elements, so this is used. So where it is used to connect different elements. Then so here we have net analysis, and then here you have bus, and then this is your junction place, and then bus entry, bus exit. And then so here on we come across place ground. So this ground is very important. Here for every circuit you design, you need to place a zero source such that it forms a closed loop. Here you can see, here we have hi source, low source, and then zero source. When you are doing with electrical circuits, we mainly focus on zero source. So zero source is nothing but the neutral point, or the reference node for the total circuit diagram, where all will connect and meet here. So this is important. Whenever you design any circuit, zero source should be connected, so that the circuit will get closed. Then after that we have zoom out, and then port. If you have any blocks like that, you can use this port. And then so there is, if you do not have any connection, you can close the connect. So these are the different um, components or buttons that they are available. At last we have place text. Here if you place text, if you click on this, you can write the name which experiment you are doing, like mesh analysis. And then you need to change the font. Font is actually very low here, so size is very small. So you can increase 24 or 28 or 30, and then click on OK. Layer, you can directly place what experiment you are doing and what is the title of your experiment. Thereafter you can design. So let us see, we'll see the mesh analysis here. So first I need to have a simple circuit. um, for that, I am considering one source with four resistors. First, I need to collect the source. First, I need to search for the source. So, sources are generally in the library, source library. Here, if you search for sources, directly you'll have source. In this source, we have different types of sources in which I require, as of now, DC source. So if you observe, when I click on DC, the part name will be displayed here, and then you can go for DC. So which type of supply is this? So the positive is connected with red and negative here. Click on OK. When you click on OK, if you observe the mouse pointer, the element which you have selected is following the mouse pointer. So wherever you place the pointer, it will move there. And if you want to place that component there, you need to give one left click, like that. So once if you apply left click, then the part will be placed. After that, if you want to remove this part from the mouse cursor, then you can go for pressing of escape button, or you can directly right click and end mode. So therefore the element will be removed. Then after this, I need to connect. Next thing I need to connect is resistances. So for that, I need to search for analog elements. In analog elements, you have different elements. Right now I require only resistance. So I have resistances 1, 2, 3, and then, so if you want to rotate, you can click on Control R, 5. So total I have 5 resistances. Now I need to connect all these to form a circuit. For that I use wire. So if you observe to the rightmost corner, you have place wire. Click on place wire. If you click on place wire, automatically this uh, cursor is changed to plus, and then just bring this cursor nearer to the element end, and then one left click, it will connect, and then you can connect to the next end. So if you observe here, when it comes to red mark, so the connection is correct. If you further move on this, so like this, if you observe, so you'll get a caution symbol where the connection is not properly connecting. So therefore first you need to check. So once the red button is seen, so directly you can click on. So if you correctly click on to the end, automatically the cursor will get free. And then similarly, the second element, I am connecting the second circuit here, and then from here I am connecting the next circuit, and then from here I am connecting it to the, like this. So in between I have two, one, and then this resistor second, and then here also fifth resistor, and then here this is your fifth resistor. So this is the completion after all the elements are connected to the source. Now I can press escape. So this is here, if you observe this, the connection between these elements, so all the elements are connected clearly. Is it clear? So then these elements are connected. Now I need to give the values of the elements. So R1 is the name of the resistance. So R1, R2, R3, R4. 1K is the value of the resistance. Right now, if you double click the value, you can change it. So I am changing it as 500, and then here 600, and then here 800, and then here 1500, and then here 1200. Like that I have taken the resistances. Click on OK, and now I am assigning the source value. So source, I am assigning it as some 150 volts. So click on OK. Now I have connected all the elements, and then I have given the resistances. Now my aim is to find out voltage across 600 ohm resistor. Let us say voltage across 600 ohm resistor. For that, what I am doing, so all these are connected, but there is no reference. So for that, first I need to connect to the ground. uh, so ground. So for that, I need to select for zero source. So click on zero source, and then connect it to the negative terminal of your source, such that this positive terminal and all the current will be coming, and it is connected to the reference point. So now after this, once the connection is over, now I need to go for create new simulation profile. You can go for PSpice new simulation profile. Then it will ask for your name. So you can give any name. So as I am doing for mesh analysis, as my original name is mesh analysis, I am giving it as mesh, simple, small, and then you need to check from none and then create. If you observe, if you create, a pop-up window is available here, and previously if you observe here, this run button is not enabled, and then you need to click on OK. So that is a setting. So again, if you observe here, click on OK, and then if you run the program, if the connections are correct, that directly it will display like this, a window display. If you have any error, so it will show the error here. So there are some errors that are there, so it will show the errors bottom of this, and then you need to rectify those errors now. So after this, once the simulation is completed, now if you observe here, there are no values or how to measure current or how to measure voltage. So our aim is to measure what is the voltage across 600 ohms. For that, if you, there are two ways. Directly you can display the voltage at each element, or you can directly find out the current. So for, if you want to display the voltage, if you click on display voltage, so this will give the node voltages of the system. Very clear. So here, here at this node it is 150 volts, at this node it is 74.27, and at this for 39.09, and this is your reference node. With respect to reference, what are the node voltages? Similarly, so this, if I click on voltage, I'll get node voltages. Now I want currents. So if you observe here, if I click on current, it will give the branch currents. So what is the current flowing through R1? What is the current flowing through R4? What is the current flowing through R2? What is the current flowing through R5? And what is the current flowing through R3? Like that. So it will give the branch currents. And if you want to measure power, directly you can measure power. So what is the power consumed by R1 resistor, R2 resistor, R3, R4, like that. So individual resistances, what are the powers? So this is one way of seeing the values. If I want to know, as I require only voltage, so if I use here, if you markers, I have voltage level marker, and then voltage differential marker, current marker, and then power dissipation marker. So each, so here you can voltage marker. If I keep voltage here, so it will give me the voltage. So once if I keep here voltage, then I'll run. So if you observe here, the voltage value is obtained here. So by placing this probe or marker, the waveform, it will not be displayed, but it comes in terms of waveform. Is it clear? Next, after this, so if you observe here, my aim is to determine voltage across 600 ohms. So but if you observe here this node, so if I want to determine the voltage across any element, I need, rather I need to not go for voltage level marker, I need to go for potential difference marker. So what is the difference between voltage level marker and a potential difference? So voltage level directly gives the uh, node voltage at that point. Now I need to know what is the exact voltage across 600 ohms. So I need to place voltage potential marker where it has two terminals. So one is positive and another one is negative. So this completes. So one voltage potential divider, potential marker has two terminals, plus V plus and V minus. So what I am doing here, I am measuring the voltage across 600 ohms. Now if I run this, so I will almost get 40 or 38 or something value. So if you want to check the value, you can directly click here. Value, displayed value, directly here. So if you observe here you can observe the waveform. And if you want to change the properties of the waveform, you can directly click on properties and you can select what pattern you want. Suppose I want a line, and the color I can change. I can change it to yellow. So most probably keep it as red. So where if you take printout, it will be good. And I need to change the width of the waveform. So why? Because if you take a printout, so this line and the grid lines are same, so you cannot differentiate the current value. So for that, I may increase the width of the value so that it will be clearly visible to the. So here, if you observe here you'll see what waveform is it. So voltage across resistor, so between which is connected between R1 and R2 terminals. So this is how you need to check the waveform. This is the potential divider. And if you observe whether it is correct or not, if you click on voltage, so 150 volts at this node I have 74.27 and then it is 39 point. So the difference of these two, you'll get it as the voltage across 600 ohms. So for that we can use. So here you can use for search for calculator, and then if you click on open, so 74.27 minus 39.09, so will gives you 35.18. So if you observe the waveform here, what you got, it is also other 35.18. So this is the um, difference. So suppose if I say that I'll place a voltage marker here itself. So I have placed the voltage marker and potential difference. So now I again run it. Now, if you observe the difference, the potential marker is which is shown in red. So it will display the voltage across 600 ohms, whereas the voltage level marker displays the voltage of the node of this particular node as 74.27. If you observe here, you will get almost all 74 volts. So that is the difference. You need to see why which one you need to connect. If anyone asks you to find out voltage across 600 ohm resistor, then you need to go for potential difference marker. If I want to node voltages, then I can directly go for voltage level markers. And if for current, I can directly click on current at each element. Clear? And then if you observe here, the colors are already identified. So green indicates voltage level marker, red indicates potential difference marker, blue indicates current marker. Now if I run this, automatically the values are here. So where current is very less with respect to the magnitudes of voltages, so you'll get the almost all zero. So or you can individually do this. Okay? So this is how to uh, do an experiment in PSpice. So this is all for today's class. Thank you.